So today we will discuss functional dependency. Functional dependency is a set of constraints between two attributes in a relation. Constraint meaning condition between two attributes. Functional dependency says that if two tuples, tuple meaning row, have same value for attribute a1, a2 to an, then those two tuples must have to have same value for attribute b1, b2 to bn. Meaning if in two rows there is in one column, if attributes are same, then in second column it will be same also. For example, if roll number 1 attribute A is roll number and attribute B is CGPA and semester, if roll number 1 has 10 CGPA in third sem, it will be same throughout the database. Roll number 1 will contain 10 CGPA in third sem in entire database. Functional dependency is represented by arrow sign, that is x determine y, where x is determinant and y is determined attribute. It can also be said that the attribute x is able to search attribute y in the database, in entire database. For example, through roll number we can search another attribute. If we ask what is the address or what is the name or father name of roll number 5, so it is easy to search. This is a table. There are some attribute meaning column. We have three attribute: employee number, employee email and employee name. So determinant always a unique attribute and minimal attribute. So here employee number is unique attribute, employee email is also a unique attribute, but we will choose a minimal attribute. So employee number can be determined, employee email and employee name. We can search if we ask what is the email of 633, then we can search in the table easily the email address and the name of related person. So here employee number determining email and name. Keys, function dependencies and keys related to it. There is key is a set of attributes that uniquely identify entire tuple. We already know it. A functional dependency allows us to express constraint that uniquely identify the value of certain attribute. फंक्शनल डिपेंडेंसी के थ्रू हम वो कंस्ट्रेंट आइडेंटिफाई करते हैं जो अदर एट्रीब्यूट को यूनिकली आइडेंटिफाई करते हैं. वो हम फर्दर एग्जांपल में देखेंगे. फंक्शनल डिपेंडेंसी के थ्रू हम पहले कैंडिडेट की ड्राइव करेंगे एंड देन मिनिमल कैंडिडेट की जो सारे एट्रीब्यूट्स को यूनिकली आइडेंटिफाई कर सकती है विच विल बी सुपर की, वो हम फंक्शनल डिपेंडेंसी के थ्रू डिटरमाइन करेंगे. यहाँ पर एक लाइन है, हाउएवर कैंडिडेट की इज़ ऑलवेज अ डिटर्मिनेंट. कैंडिडेट की ऑलवेज लेफ्ट हैंड साइड होगी जो डिटर्मिनेंट है और जो यूनिक एट्रीब्यूट है, मीनिंग वो which is able to search another attribute in the database is a candidate key, but a determinant doesn't need to be a key. ये फिक्स नहीं है, ये ज़रूरी नहीं है कि डिटर्मिन जो फंक्शनल डिपेंडेंसी है वो ऑलवेज एक कैंडिडेट की हो. अगर वो कैंडिडेट की नहीं होती है तो उसे कैंडिडेट की बनाना होता है, वो हम एग्जांपल में देखेंगे. देन आर्मस्ट्रॉन्ग एक्सियोम्स, आर्मस्ट्रॉन्ग रूल्स रिलेटेड टू फंक्शनल डिपेंडेंसी. इफ इज अ सेट ऑफ फंक्शनल डिपेंडेंसी देन क्लोजर ऑफ एफ डिनोट्स एज एफ प्लस. क्लोजर को प्लस साइन के साथ डिनोट करते हैं. अगर ए एफ का क्लोजर तो इट विल बी एफ प्लस. इज अ सेट ऑफ ऑल फंक्शनल डिपेंडेंसी लॉजिकली इम्प्लाइड बाय एफ. Armstrong axioms are a set of rules that when applied repeatedly generate a closure of functional dependency. हम क्लोजर डिटरमाइन करते हैं ये पता करने के लिए कि फंक्शनल डिपेंडेंसी सारे एट्रीब्यूट को यूनिकली आइडेंटिफाई कर सकती है या नहीं. अगर वो यूनिकली आइडेंटिफाई कर सकती है तो वो उसको सुपर की सेट कर सकते हैं. तो आर्मस्ट्रॉन्ग एक्सियोम्स रूल्स क्या हैं, वन बाय वन देखते हैं. First is reflexive rule. If x is a set of attribute and y is a subset of x, then x determine y holds. अगर एक एट्रीब्यूट रोल नंबर, फॉर एग्जांपल रोल नंबर अगर नेम को डिटरमाइन कर सकता है तो रोल नंबर और नेम का कॉम्बिनेशन भी नेम को डिटरमाइन कर सकता है. देन ऑगमेंटेशन रूल, अगर रोल नंबर ऑगमेंटेशन इफ ए डिटरमाइन वाई, it is true, it is whole, it holds, and y is attribute set, then ay tends to by is also true. अगर a b को डिटरमाइन कर सकता है और a के साथ एक और एट्रीब्यूट ऐड कर देंगे तो b के साथ भी सेम एट्रीब्यूट ऐड करेंगे, वो कंडीशन, वो फंक्शनल डिपेंडेंसी भी उस रिलेशन में ट्रू होगा. फॉर एग्जांपल अगर रोल नंबर नेम को डिटरमाइन कर सकता है तो रोल नंबर और CGP का कॉम्बिनेशन भी नेम एंड CGP के कॉम्बिनेशन को डिटरमाइन कर सकता है. ट्रांजिटिव रूल, it is simple to algebra. A tends to B and B tends to C, or A determine B and B determine C, then A also can determine C. Here determine meaning can search. If A is able to search B in the database and B able to search C in the database, then A will be able to search C in here. Then the union rule, if x tends to y and x tends to z, we also can write x tends to yz. Decomposition is just revert. If x tends to yz, we can also write x tends to y and x tends to z. Then pseudo transitive rule, if x determine y, because x is able to determine y, meaning x is a strong attribute or stronger than y. So in the relation wy tends to z, we can replace y with x because x is stronger than y. So x tends to z is also true. Next, trivial functional dependency. The word trivial meaning, the synonym of trivial is negligible, meaning no use, which can be removed. So similar in here, the term used here, trivial meaning, if a functional dependency x tends to y hold, where y is a subset of x, then it is called a trivial functional dependency, meaning if the attribute which is determined is a subset of determinant. In this example, roll number is uniquely able to search name, and we are adding name with it, it's no use, so it is trivial. Trivial meaning, in left hand side and right hand side, intersection is not phi. If we calculate intersection of x determine y, intersection of x and y, it will not be phi. So it is a trivial case because only roll number is able to determine y, so adding another attribute is negligible, not useful, or trivial. So non-trivial case is revert when there is no common attribute, meaning intersection will be phi. Like in this example, roll number and name, they are two different attributes, there is no common here. Next, here we will discuss closure, candidate key, and super key. Closure already we have discussed, it is represented with plus sign. So f is a functional dependency, then f closure will be f plus. Super key is a minimal candidate key. First we need to calculate all candidate keys, then we will search the minimum candidate key to set it at super key. So let's go with the table. There is a table. There are five roll number and 5 name. So what written here? X is determinant and y is determined attribute. Roll number is determining name, meaning roll number is able to search name in the table. So here it is written with change in determinant, determined can remain same. Okay, meaning roll number 1's name is Ankit and roll number 2's name is also Ankit, while determinant is changing 1 to 2, while determined attribute is same Ankit. It's fine, it is possible in database. Roll number 1's name and roll number 2's name is same, but with different determinant or change in determinant, with different determined attribute or change in determined attribute, determinant must change. If name is Ankit to Shyam, then roll number must change 1 to some other roll number. We cannot write it Ankit's roll number is 1 and Shyam's roll number is also 1. It is not possible. As it is written here, x1 tends to y and x2 tends to y. It's possible, meaning roll number 1's name is Ankit and roll number 2's name is Ankit. It's possible, but x tends to y1 and x tends to y2 both. This is not possible, meaning roll number 1's name Ankit and roll number 1's name is Shyam also. It is not possible. So this is the condition with functional dependency. According to this condition, we can check that functional dependency is true or not. That we will see in this example. We need to check which one is false, which functional dependency is false. So there is a relation R which contain 5 attribute A, B, C, D, E. So we need to check which one is not true. So first A tends to BC. So here A meaning A tends to BC, meaning first attribute is 2, 3. A determining 2, 3. We can consider it as roll number. So A is a different roll number determining 2, 3. It's fine. 2 is different roll number determining A3 is different name. 2, 3 and A3 are different. So it's fine. Then roll number A meaning roll number 1 again determining 2, 3. It's fine. Roll number 1's name 2, 3 and roll number 1's name 2, 3. It's fine. Again A determining 2, 3 meaning roll number 1's name 2, 3. It's fine. So it's fine. It's right. There is no problem in that. Then we will go for second one. DE determines C. Let's check it is true or not. So DE is 4, 5 first, 4, 5 determining 3. 4, 5 we can consider 4, 5 as one roll number. So roll number 1 determining name 3. It's fine. Roll number 1 again name 3. It's fine. 6, 5 another roll number, so we can consider it as roll number 2. Roll number 2 determining name 3, so 2 roll number can have same name, no problem. 6, 7 is another roll number. We can consider it as roll number 3. Roll number 3 determining same name, still no problem. 3 roll number can have same name, so it's also fine. So there is no problem in B option also. Then we will go for option C. C determine DE. Yes. So C is 3. 3 determine DE is 4, 5. We can consider C as roll number 1. So roll number 1's name is 4, 5. It's fine. Roll number 1's name is 4, 5. Again, it's fine. Then roll number 1's name is 6, 5. It's not true. One roll number cannot have different name. So there is a problem in option 3. And roll number 1 again has name 6, 7 or it's related to 6, 7. So it's option 3 is false. Then we do not need to check further because option 3 is false. Next we will see closure, how to calculate closure, and then candidate key and then super key. So there is a relation R tends to A, B, C, D, E, F, G, meaning there are 7 attributes in the relation named as A, B, C, D, F, G. It can be anything like roll number, name, address, age. So x plus is closure. So x plus set of all attribute determined by x. x जितने attribute determined कर सकता है maximum, वो उसका closure होगा. हम एग्जाम्पल देखेंगे. फंक्शनल डिपेंडेंसी सेट है हमारे पास जिसमें 5 फंक्शनल डिपेंडेंसी हैं. फर्स्ट ए टेंस टू बी, then second BC tends to D, third B tends to C, then PD tends to E and EF tends to G. तो हम वन बाय वन ऑल फंक्शनल डिपेंडेंसी का क्लोजर कैलकुलेट करते हैं. सबसे पहले A टेंस टू B का के लिए क्लोजर कैलकुलेट करेंगे. तो A लिखा, A के साथ B, बिकॉज A इज़ डिटरमाइनिंग B, सो यहाँ पर ए बी आ जाएगा। देन ए के साथ बिकॉज ऑफ फर्स्ट फंक्शनल डिपेंडेंसी ए प्लस मीनिंग ए के साथ बी आएगा, बी से सी ड्राइव हो जाएगा, तो यहाँ तक ए बी सी टर्म मिल जाएगा। अब हमारे पास बी एंड डी दोनों, सॉरी बी एंड डी, ए से बी ड्राइव हो जाएगा एंड बी से सी ड्राइव हो जाएगा एंड बी सी, हमारे पास टर्म बी सी दो है और बी सी से इस फंक्शनल डिपेंडेंसी से डी ड्राइव हो जाएगा एंड बी डी अब दोनों यहाँ पर प्रेजेंट हैं, तो बी डी से ई ड्राइव हो जाएगा। हम देखेंगे कि यहाँ पर जितनी फंक्शनल डिपेंडेंसी हैं, इनकी किसी भी फंक्शनल डिपेंडेंसी के राइट हैंड साइड में एफ नहीं है, मीनिंग एफ किसी से डिटरमाइन नहीं हो पाएगा। तो ए पॉसिबल, ए का जो क्लोजर है वो ए बी सी डी ई तक ही डिटरमाइन कर सकता है, वो एफ़ को डिटरमाइन नहीं कर पाएगा क्योंकि एफ़ राइट हैंड साइड नहीं है कहीं पर भी, और क्योंकि ई एफ से ही जी डिटरमाइन हो रहा है, इसलिए जी भी डिटरमाइन नहीं हो पाएगा। तो ए's closure will be A B C D E, but A is not a candidate key. Why? Because candidate key must determine all attribute. A is not able to determine F and G, so it is not a candidate key. But F's closure is A B C D E. फिर next we will go with B C tends to D. Next functional dependency. Then we explore it B C. BC tends to D, so we can write it here BC and D, and BD can determine E here. BC can determine D and BD can determine, B and D both are available now, so BD can determine, we have D also, we have D also, BD can determine E, so B, C, D, E. For BC's closure will be B, C, D, E, but it is also not a candidate key because attributes are remaining. A is not here, F is not here, G is not here, so it is not a candidate key. Candidate key must determine all the attribute. Then we will check another functional dependency, that is B tends to C. So B can determine C, so B's closure will be BC. Then next functional dependency, it will stop here only. It is not able to determine many attributes like A, E, F, G. Then fourth is BD. BD's closure is BD can determine E, so it will be BD plus will be, there will be E here. It will be E here. And the last one is EF. EF can determine G only, then its closure will be, EF's closure will be EFG. When we explore it completely, it will be EFG, no other attribute will be added. So no one is candidate key here, all functional dependency. Now we need to convert those into candidate key. How to convert functional dependency into candidate key, and how to find that minimal candidate key to calculate super key. So the first key we have, the first functional dependency was A tends to B. When if we add F into this, if we add, here are A, B, C, D, E, only F and G is not here. If we add F here, then EF, E is already here. If we add only F, then EF can determine G. Then all attribute of the relation A, B, C, D, E, F will be there. So AF can be a key. Then In the second case, if BC's closure is BCDE, if we add some attribute here, if we add F, then it can determine in this there are 4 attributes. If we add A here, BCA, then it will then B C D E and A will be there, and if we add F here, then because of E F, G also will be there, so B C A F will be a key. Then we check third functional dependency, that is B tends to C, so B will determine C, and BC, there will be 2 attributes, BC determine D, so D will be there, and remaining attribute, if A we will add A here, then an F here, then all attribute A B C D E F G will be it will cover complete relation. Then similar for EF. So now we have 5 candidate key, AF, and so we have 5 candidate key, AF and remaining 4. The minimal candidate key is AF, meaning here are only 2 attributes while there is 4 and 3 attributes, so it will be super key in the relation. So which is all about closures, candidate key, super key and functional dependency. Thank you.